Good Monday on this Labor Day. Since we last spoke on Friday, there's been a lot of changes that have happened with Hurricane Irma. It's remained a major Category 3 storm with minor fluctuations up and down in terms of its intensity. But let's get down to the change in the forecast track. This is from the National Hurricane Center. Latest update coming in at 11 o'clock this morning. Category 3 storm, but winds now up to 120 miles per hour. Gusts upwards of 150. Within the center of that system. Now, the forecast track has been shifted farther to the south, moving through the southern part of the Caribbean and the Bahamas, and eventually somewhere near Cuba, maybe even on the north side, north coast there, making a landfall there by the early part of the weekend. Notice that at this point, about a 500-mile spread in terms of that cone of uncertainty. Remember, we talked about that. Each day that you go out, the uncertainty or the level of error grows significantly in terms of our computer models. So the farther out you go, we're getting about a 500-mile spread there. This certainly puts the southern tip of Florida in the crosshairs by the time we get to the later part of this weekend. Also, some cool things happened over the weekend. National Hurricane Center actually shuffled around some assets and flew down a P-3 Orion aircraft. Now, these are not just your run-of-the-mill average airplanes that fly into storms. These are run by the hurricane hunters, and they are equipped with some really cool equipment. The first we're going to talk about are GPS dropsondes. Now, what these are is these are tubes that they shoot out of the back of the airplane, and what they do as they travel to the surface is they take samples of the air pressure, the temperature, humidity, and the wind speed for all levels, and then they input that data into the computer model, so some real-time data there. On top of that, they have Doppler radar equipped on board. Two types of it. The first is the lower fuselage, and the second is the tail Doppler radar. One shoots at the storm horizontally, one vertically. In turn, they pretty much get an MRI of the storm, and they can see all the internal structures there as they're flying through it. And then on top of that, microwave radiometers. Really cool piece of equipment there. This actually senses the wind speed on the surface of the ocean. How does it do that? It actually measures the radiation coming off of sea foam that's churned up from the rough waves in the center of the storm. I know, quite unbelievable there, but that's exactly how they do it there and get the sense of that wind speed at the surface of the ocean. Let's talk about the two missions that have already gone underway. The first was last night on Sunday evening. Flew into the storm, and they found winds of 113 miles per hour in the northeast quadrant of the storm. You got to think of a hurricane, you cut it into four sections. The northeast or the top right is always going to have the strongest winds as it's moving in forward momentum. That's where you're going to find the strongest wind gusts and the strongest sustained winds as well. So 113 miles an hour last night. But then this morning's mission, less than 12 hours later, they went right back into the storm and they found winds of 131 miles per hour in that same quadrant, indicating some intensifying in the last 12 hours as it moves into an area that's very, very conducive for it to continue on this growth spurt. Now, I want to show you here the satellite imagery because you can see there in the last couple frames, we're starting to lose glimpse of the eye again. In fact, I want to go all the way back 48 hours and do a loop here from Saturday early afternoon. If you watch it over the general time frame here, we see the eye disappear, the eye reemerge, the eye disappear. In fact, I counted around 3 separate eye wall replacement cycles going on. Not uncommon to find these in storms that get this intense this quickly. And what that is the storms, the thunderstorms that build around the center, they build inwards, and eventually they cut off the energy flow there. The storm kind of resets itself and then rebuilds a separate eye wall as it continues off on the westwards track there. And you see it time after time redeveloping there. And I think it's underway on another eye wall replacement cycle as we speak. Still very, very far away from the eastern seaboard. More importantly, Hampton Roads, around 1,800 miles away from us at the current time. That gap has been closing, obviously, throughout the entire weekend. We switch up that view there and throw up the water vapor imagery. This depicts dry air from very moist air. You can depict the drier air in the reds there and the browns, and then the moist air all around the system there. Notice no dry air getting pulled into it, so that should not be an issue to inhibit any further growth there. On top of that, moving into very, very warm ocean waters, anywhere from a half a degree to a full degree above average. Now, I know that doesn't sound like much, indiscernible to you and I, but that's all that much more energy for this storm to use as fuel. In fact, the warm waters aren't just at the surface. They extend down to great depths. That means as the storm moves off into the Bahamas and it slows down, like it's forecast to do, something that we call upwelling won't be so much of an issue. Upwelling is when the storm is so intense, it kind of mixes up the ocean waters, and pulls up the cooler water from below and in turn cools down the ocean surface. That won't be so much of an issue as we go through the next several days with this, since the warm water extends to such a depth that upwelling will not really stop it. As it's moving into the Bahamas, that's where you're going to find some of the warmest waters in the Atlantic. We're talking temperatures 86, 87, 88, even 89 degrees as you get towards the Bahamas there. It is forecast to track right along the north coast of Cuba currently. It could certainly change from here on out. Let's revisit that tropical tracker from Hurricane Irma from the Hurricane Center there. And I want to talk to you about what exactly is going on that's going to be steering this. We've talked in previous videos about the Azores or the Bermuda High that's going to be steering out over the Atlantic. Well, there's a separate feature that's going to be diving in from the north and west. And what that's going to do is it's going to try and pick up Irma and lift it northwards. It's a trough that's moving on through. Now that that storm is depicted to kind of slow down as it moves through the Bahamas, you almost have to think of it as the northbound train is leaving the station, but Irma's arriving at the platform just as it pulls away. This is likely going to just move on through here before Irma can reach it, as it looks right now in the computer models. What's going on also is the Weather Service offices way out in the upper Midwest are actually going to be sending up weather balloons every 6 hours for the next few days instead of every 12 hours to get a better gauge on how strong this trough is and the movement of it and the features as it heads on towards this area. So that'll also be crucial in lifting Irma off towards the north. And when that turn happens is also going to be very, very crucial here to see how it all pans out. Let's talk about the two major models now, the GFS and the Euro. First, I want to dispel some rumors that's been going on with the GFS model. A lot of you, if you've been paying attention and accessing the models in your leisure at your home, you've seen some of these models depicting a low pressure system, the center of Irma, sub 900 millibar low. That's just not feasible. In fact, there's some reasons why that's been happening. The computer model itself had some tweaking done to it back in July. So ever since then, it's been over-amplifying a lot of these hurricanes. On top of that, this particular model, the GFS, does not accurately depict the ocean and atmosphere interaction. So it's not really gauging the sea surface temperatures as much as you would like, as much as the European model does. In fact, that shows no bias to that at all. But as we go through the next few days here, we're putting them both on top of each other, overlaid, and you see the purple indicated by the GFS, and the orange is the European model. Very good consensus here as it scoots on by near Puerto Rico and San Juan and up towards Hispaniola, scooting just to the north side coast there, and then eventually possibly somewhere making landfall along the north coast of Cuba. If it makes it too far inland, that could definitely weaken it because very mountainous region there in central Cuba, and then it takes that hard turn off towards the north. Another reason why a lot of these computer models, or the GFS in particular, has been over-amplifying this, and it's just not feasible, is because once it makes it far enough to the north, when storms travel poleward, they eventually lose their strongest sustained winds, and they're actually spread out over a larger area. We saw this happen with Matthew and then again with Sandy as well. So it'll likely not sustain itself to be as strong, but if it does make it this far north, it would likely impact more of an area with stronger winds. Also something to take note of, a storm system with that intense of a central pressure, that low of a central pressure, likely not a feasible thing either, because the lowest central pressure ever recorded east of Florida and north of the Caribbean was Gloria back in 1985, and that was down to 919 millibars. So not out of the realm of possibility. Certainly anything's possible, but not very likely of that happening with the GFS current outputs on that being some monstrous storm sub 900 millibars. Not likely here. So I want to look at the plots now. Remember we talked about these, the ensembles. This is the same computer model, the GFS we're looking at here, and dozens of runs of that same model with just a slight tweak at the time it starts there. Watch what happens here. Each run, again, dozens of these, very consistent at the start, and then by the time we get towards the later part of the forecast period here by Thursday in the afternoon, there's a quite considerable spread here, still about 600 miles, depending on the Gulf Coast of Florida and the Panhandle all the way up to possibly the Mid-Atlantic there. So everybody still is threatened, but There's nothing really to kind of pinpoint exactly where that would be. Now, I also want to compare here what's happened over the last 24 hours. Sunday morning's runs were farther off to the north and west here, but look what happens by this morning. A definite drop off to the south here, but they all do still make that hook somewhere around southern Florida. And where that happens is really going to be the million-dollar question here as it moves off towards the northwest there. Hey, I love you watching the video. Thank you so much. If you have any questions, you can find me on social media, Facebook, Meteorologist Tim Pandajis, and then again on Twitter, 13 Tim Pandajis. We'll try to put out another video tomorrow. Until then, try to enjoy your Labor Day.